A few months ago, I purchased an Arcade1UP sit-down Outrun cabinet that was on sale on the official Arcade1UP site. I really wanted the stand-up version but could not find one and did not want to miss out on getting the cabinet as I did with Star Wars. In my opinion, the Outrun cab is one of the best Arcade1UP has produced. However, other than wanting to make it a stand-up cabinet, the two things I wanted to replace were the gear shifter and the throttle brake pedals. Although they function just fine, I just preferred these controls to be more sturdy. In a previous video, I replaced the gear shifter with an arcade quality one I purchased from AliExpress for about $45. I also purchased another one for $20 to see if that would work as well, and it does. With the gear shifter replaced, the next thing on my list was to replace the pedal controls. Again, the stock Arcade1UP pedals work fine, just wanted to put some arcade quality pedals in that were a bit more sturdy. After examining how the stock Arcade1UP pedals worked, I found hooking up arcade quality pedals would be pretty easy to hook up. In fact, you can hook up any pedals that use potentiometers. So in this video, I'm going to show you how to hook up two different arcade quality pedals to your stock Arcade1UP Outrun and include how to connect the wiring to be able to plug into the stock Arcade1UP Outrun cabinet. So the first thing I needed to do was to understand how the pedals work on the Arcade1UP stock Outrun cabinet. So I opened up the pedals. So you open it up from the bottom, there's about 8 screws that hold it in, and then you remove the plate, and this is what it looks like on the bottom. So as you can see on the top here, it consists of 2 rotary 5K potentiometers. Now for those who don't know, a potentiometer is a type of passive variable resistor with 3 terminals used to get the desired voltage division. That's one definition of it. So if you look at the image on the bottom, you can see what a potentiometer looks like on the inside. It has a resistive strip and a wiper that is adjusted by the knob. When the knob is moved clockwise or counterclockwise, the pot tunes the voltage, which will allow to control the current flowing in the electrical current and a change to output voltage or resistance. For the pedals, output adjustments determines how much acceleration the throttle gas will allow or how much to decelerate when the throttle or brake pedal is pushed. The more pressure applied to the throttle or brake pedal, the more it will accelerate or decelerate. Use less pressure on the pedals and the acceleration or deceleration will not be as dramatic. Now, potentiometers, or pots as they are referred to, are rated by a resistance ranging from 1K to 50K. In the case of the Arcade1UP Stock Pedals, the resistance of the pots are 5K. The pots have 3 prongs. If you look at the image below, you will see an image of the pot upright with the prongs pointing at you. The left and right prongs will be the positive or plus VCC voltage or the negative or ground. From what I've researched, some use the left as the plus VCC and the right prong as the ground, while others have used the left as the ground and the right as the plus VCC. From what I've researched, it doesn't matter which way you set it up as long as you keep it consistent. The middle prong is the output of the voltage based on how the pot knob is turned. In the case of the pedals, when pressing down or letting up on the pedals, that will turn the potentiometer, and the output will determine if you decelerate or acceleration depending on which pedal you press. Each of the wires coming from the pot prongs plug into a 3-pin JST-XH connector on the circuit board. The input from the circuit board then outputs to a 3.5mm male 4-pole connector via the 4 wires coming out of the circuit board. Now on my picture here, you'll notice that the wires are not showing. This is because the wires connected to the circuit board are very fragile and will come off the circuit board if you're not careful. I took the board out and put back in so often during this video that they came off. This is fine as I can solder them back on or rewire it in a way where I don't even need the board, which I'll explain later. At any rate, you may know what a 3.5mm adapter looks like, as it is usually the adapter you use to plug headphones in. But what does it mean when I say it's a 4-pole adapter? If you look at the image to the left, you'll see 3 different 3.5mm male adapters indicating how many poles they use. The pole is determined by how many rings are on the male adapter end. Each section between the rings indicates how many wires are used in the cable to carry whatever data is needed. For the 2-pole, we see there is only one ring, and above the ring would be audio, and below the ring would be ground, indicating 2 wires are being used. For the 3-pole, you have 2 rings. Above the top ring would be the left audio, the section between the top and bottom ring would be the right audio, and the section below the bottom ring would be the ground, indicating that 3 wires are used for this cable. For the 4-pole, you have 3 rings. Above the top ring, you have left audio. Between the top and middle ring would be the right audio. Between the middle and bottom ring would be ground. And finally, below the bottom ring would be the microphone, indicating that 4 wires are used for a 4-pole 3.5mm cable. Now, in this implementation of a 4-pole 3.5mm cable, this would be used for a headset with a microphone on it. For the Arcade1UP Pedals, the wires would be designated differently, and that is what I need to determine before going forward. This is a diagram of how the Arcade1UP Stock Pedals are set up. If you open the bottom of the pedals and look straight at it, this is a diagram of what it would look like. On the left is the 5K pot used for the throttle, and on the right is the pot used for the brake. You may be looking at this diagram and thinking the throttle should be on the right and the brake on the left. However, we are looking at this from the back. If we flipped over, then the pedals would be in the correct orientation. But because we have it upside down so we can take the cover off, the orientation of the throttle and brake pedals are switched. With that said, the green cable on the pot represents the ground cable. The white cable is the output for the throttle and the brake respectively, and the blue cable represents the positive VCC voltage. Also, if you imagine the pot standing upright and the prongs pointing towards you, the throttle pot has the ground on the left prong and the positive VCC on the right prong, whereas the brake pot has the positive VCC on the left prong and the ground on the right prong. Again, it doesn't matter which prong is positive VCC or ground, as long as one is positive VCC and one is ground. I believe Arcade1UP did this in this way so that when you look at both pots, the positive VCC and the ground prongs line up as shown in the diagram. When I show you how to connect the arcade pedals, I will keep them uniform, meaning that both pots will have positive VCC on the left prong and ground on the right prong. But for the stock Arcade1UP, the pots are set up in the way shown. Each pot connects to the circuit board and plugs into a JST-XH connector. The circuit board then outputs the signal through the 4 cables on the 3.5mm 4-pole cable. The male end of the 3.5mm 4-pole cable plugs into a female 3.5mm 4-pole connector, which then goes directly to the Arcade1UP Outrun encoder board. So the question is, the cable's coming from the pots number 6 cables, but is outputting to the 3.5mm 4-pole cable that has 4 cables. This conversion is done on the circuit board that the pots plug into. So is there anything special, such as special circuitry or anything like that, on the circuit board that is making this conversion? Well, the answer is no. There is no special circuitry on the circuit board. The circuit board just makes the connection more convenient and easier when connecting the pot cables to the 3.5mm 4-pole cables. So let me explain and show you what I'm talking about. In this diagram, we see the top view and bottom view of the circuit board in question. In the top view, you see the JST-XH connector on the left is for the throttle and the right one is for the brake. Each pin is labeled what each wire is on the pot and what color it is. The wires on the right are the wires that are part of the 3.5mm 4-pole cable. If we flip the circuit board over, we see the bottom view. Since we are looking at the bottom, the position of the positive VCC and ground cables are inverted, as are the wire colors for the 3.5mm 4-pole cable. Now notice the trace routes on the circuit board. If we apply an overlay of the trace routes and color code it to the colors of the pot cables, we notice that the pot wires for the positive VCC throttle and brake are both connected to the same trace routes and are going to the same green wire on the 3.5mm 4-pole cable. The same happens with the ground for the throttle and brake. The trace route connects both pot ground wires to the same black wire on the 3.5mm 4-pole cable. The throttle and brake output pot wires have their own individual trace routes, with the throttle going to the white wire and the brake going to the red wire on the 3.5mm 4-pole cable. So to summarize, the positive VCC and ground pot cables for the throttle and the brake output share the same wires on the 3.5mm 4-pole cable. So all the circuit board is doing is making sure that there is a trace route for the positive VCC and the ground, so they are connected to the same wires on the 3.5mm 4-pole cable, which means that this circuit board is not even needed to use the pedals. The circuit board is there just to make it easier to connect the positive VCC and ground wires from the throttle and brake pots to a single wire on the 3.5mm 4-pole cable. So this is a diagram representing how the stock Arcade1UP pedals would be connected without the circuit board that connects to the pot wires to the 3.5mm 4-pole cable. If the circuit board was taken out, you could splice the pot cables directly to the stock Arcade1UP 3.5mm 4-pole cable, or with a different 3.5mm 4-pole cable if you cut the end off to expose the wires. There are two options that show how the pots are wired to the 3.5mm 4-pole wires. Each option shows a legend that indicates what color wire on the 3.5mm 4-pole cable is spliced or connected to which pot cable. The Arcade1UP Stock Pedals have cables that are colored. However, the color of the cables coming from the pots are not important. What is important is to make sure the pot wire's designated function corresponds with the color wire on the 3.5mm 4-pole cable. Option 1 shows the wires running from the positive VCC throttle and brake pot prongs being spliced to the green wire on the 3.5mm 4-pole cable, which represents the voltage. The same is done for the ground pot wires. You run wires from the brake and throttle ground prongs on the pot and splice to the black wire on the 3.5mm 4-pole cable, which represents the ground. Then you would run a wire from the throttle output and splice to the white wire, and run a wire from the brake output and splice to the red wire on the 3.5mm 4-pole cable. Option number 2 is similar. However, instead of running the two pot wires from the positive VCC and the ground and splicing them to the appropriate wire on the 3.5mm 4-pole cable, we are only going to run the positive VCC and ground wire from the throttle pot and splice to the appropriate wire on the 3.5mm 4-pole cable. So to do this, first look at the wire running from the brake pot positive VCC prong. That wire is connected directly to the positive VCC prong on the throttle pot prong. Then another wire is run from the throttle pot positive VCC prong to the green wire on the 3.5mm 4-pole cable. The same procedure is done on the brake pot ground wire. The brake ground wire is connected to the throttle pot ground prong. Then another wire is run from the throttle pot ground prong to the black wire on the 3.5mm 4-pole cable. Doing it this way allows only splicing one positive VCC and ground wire to the 3.5mm 4-pole wires instead of two shown in option 1. Then, as we did in option 1, you would run a wire from the throttle output and splice to the white wire, and run a wire from the brake output and splice to the red wire on the 3.5mm 4-pole cable. Now, of course, we're not going to do this on the stock Arcade1UP pedals, as the pedals are working properly. This is basically to show you how you would do that without the circuit board, or if the circuit board was damaged. So if anything happens to that circuit board, or if the 3.5mm 4-pole wires come off, like they did in my case, you do not necessarily have to solder them back on the circuit board, and you have a different option to fix the issue. But more importantly, because the circuit board is not needed, this means that any arcade pedals with 5K pots can more than likely be connected to the stock Arcade1UP Outrun cabinet, as the only thing that needs to be done is to wire the pots correctly to a 3.5mm 4-pole cable with a male connector. Okay, so now we have to figure out how to create the cables that we will use to connect the arcade pedals to the Arcade1UP Outrun cabinet. Now there are many ways you can do this. This is the cable that I took out of the Arcade1UP Stock Pedals. Since the cables broke off the circuit board, I could splice the cables together onto the pots. But in your case, the cable is just fine, so no need to take the cable out just to connect to Arcade Pedals, as you may want to have the Arcade1UP Stock Pedals around in case you decide to sell the unit. You could buy a 3.5mm 4-pole cable and cut the end off to splice, or could make your own cable. However, the wires in the 3.5mm 4-pole cable are very thin and hard to strip. Also, making your own cables requires getting crimpers and possibly special tools to terminate the male 3.5mm ends. However, there is an easier way to make the cables we need without all the need of special tools, crimping cables, or having to cut off ends of cables to make the cables that we need. So the cable we're going to use is a 3.5mm to 4-pin screw terminal. Now on one end of this is the 4-pole male connection, and on the other end is a terminal block with 4 connections. Now these cables come with a little screwdriver so you can unscrew the connections, and then basically what you do is you unscrew it and you'll stick a cable in there, and then you'll screw it down to hold it in place. Now this will allow us to easily take the wires from the Arcade pedals that are on the pots and easily connect them to these terminal blocks so that we don't have to use soldering or crimpers or anything like that to create the cables. Now because these cables are relatively short, you'll want to buy a male to female extension cable just to give you extra length so it can connect to the Arcade1UP female connector. Just make sure that it is a 4-pole cable extender, or else it's not going to work. But once you got it connected up, and once you connect that connector, and once we got the cables connected to the terminal block for the Arcade pedals, that's all you should need in order to connect this to an Arcade1UP Outrun cabinet. If using the 3.5mm to terminal block connectors, we have to know where to connect the wires from the throttle and brake pots. The diagram represents the 3.5mm 4-pole to 4-pin screw terminal block. On the cables, each terminal on the terminal blocks are labeled with a letter or a symbol. The letters or symbols are hard to read on the actual cable, so I have typed them in white on the pictures to clearly define what they are. The picture shows the 3.5mm to 4-pin terminal block and the legend where each pot wire goes in the terminal block. Going from right to left on the 3.5mm terminal block, you have the terminal with the ground symbol. This is where the throttle and brake ground wires will be screwed into. The terminal port marked with the letter V is where the throttle and brake plus VCC wires will be screwed into. The third terminal port marked with the letter R is where the throttle output wire is screwed into, and finally the fourth terminal port marked with the letter L is where the brake output wire would be screwed into. So before we can continue, you have probably noticed that there is nothing color coded. When using these connectors, the color of the cables does not matter. The only thing that you need to do is make sure that the wire that comes from the pot goes in the correct terminal block port. So here's a diagram showing what it would look like if using the 3.5mm to terminal block connectors on a stock Arcade1UP pedals. Again, we are looking at the image from the back of the pedal enclosure, so that is why the throttle is on the left and the brake is on the right. You can see how the pot wire should be connected to the terminal block by looking at the legend. Again, in this case, the color of the pot cables does not matter. It is convenient to have the pot wires color coded so you know what they are by looking at them. However, what is most important is the designation of the pot prong and that the wire plugs into the correct terminal port. For example, the positive VCC cable is blue, but would not matter if the wire is black, white, green, or any other color. The important thing is to make sure the wire coming from the pot positive VCC prong is going to the terminal port labeled with the letter V. Finally, you do not have to use this modification to the stock Arcade1UP pedals. This is just informational to show you what it would look like if you did actually do this. However, if anything happens to the stock 3.5mm cable on the stock Arcade1UP pedals, you can repair by following these diagrams. So most arcade pedals use pots for the brake and throttle, but in some cases microswitches are used. For example, for the arcade pedals that are pictured here, there is a pot used for the throttle, but for the brake there is a microswitch used instead of a pot. So although the Arcade1UP Stock Outrun pedals use pots for the throttle and the brake, could an arcade microswitch be used instead of a pot? And the answer is yes, but it must be a 3-prong arcade microswitch. Here's a picture of a potentiometer and a 3-prong arcade microswitch. As we have gone over before, when you stand the pot upright and point the prongs out towards you, the left prong can be used as the positive VCC and the right prong can be the ground, or the left prong can be the ground and the right prong can be the positive VCC. The output is on the middle prong of the pot. We can simulate the pot using the 3-prong arcade microswitch. However, the prongs for the positive VCC and ground cannot be interchanged. With the 3-prong arcade microswitch, in the orientation shown, the top prong is for ground, the middle prong is for positive VCC, and the bottom prong is for the output. Again, unlike the pot, the ground and positive VCC cannot be interchanged and have to be wired to the appropriate prongs, or the throttle and brake will not operate properly. So in this diagram, imagine if the stock Arcade1UP pedals had 3-prong arcade microswitches instead of pots. If we splice the wires from the microswitch to the Arcade1UP stock 3.5mm 4-pole cable, we have two options like we did with the pots. In option 1, we take the 2 ground wires from the throttle and the brake microswitch and splice them to the ground cable or wire on the 3.5mm 4-pole cable, which is the black wire. The positive VCC wires from the throttle and brake microswitches are spliced together to the 3.5mm 4-pole wire for the positive VCC, which is the green wire. The throttle and brake output cables are then spliced together to the appropriate wires on the 3.5mm 4-pole cable, with the throttle wire from the microswitch spliced to the white wire and the brake wire from the microswitch spliced to the red wire on the 3.5mm 4-pole cable. In option 2, it is similar, except we take the positive VCC and ground wire from the brake microswitch and connect to the positive VCC and brake ground on the throttle microswitch. Then we run another wire from the throttle positive VCC and ground and splice to the appropriate wires on the 3.5mm 4-pole cable, which would be black for ground and green for positive VCC. The throttle and brake output wires are spliced to the same wires as in option 1, with the throttle wire spliced to the white wire and the brake wire spliced to the red wire. Connecting the 3-prong arcade microswitches to the 3.5mm 4-pole terminal blocks are the same as connecting the pots in the Arcade1UP Stock Pedals. Looking at the 3.5mm 4-pole to terminal block diagram, we look at the legend and connect the microswitch wires to the appropriate ports on the terminal block. Going right to left, both the throttle and brake microswitch ground wires are connected to the terminal block port with the ground symbol. The throttle and brake microswitch positive VCC is connected to the terminal block port with the letter V. The throttle output from the microswitch is connected to the terminal block port with the letter R, and the brake output wire from the microswitch is connected to the letter L terminal block port. You may have noticed I did not mention the colors of the microswitch wires. As with the pot wires, the color of the wires do not matter. What matters is that each designated wire from the microswitch is connected to the corresponding port on the terminal block based on the legend for each scenario. Okay, so now that we know everything works and how the pots and microswitches should be wired, we can now test different arcade pedals. So the first set of pedals we will test are the Modular Pedals from Zuzo Hat. These pedals are about $73 a piece before taxes and shipping, and 2 are needed for the brake and the throttle. The second set of pedals we will test are the dual pedals with dual 5K pots, also from ZuzoHap. The pedal set would go inside the Arcade1UP riser and cost around $152 before tax and shipping. Finally, I will go ahead and test 2 arcade buttons with microswitches. Now the microswitches I use are from a previous project, and not sure where I purchased, but as long as the microswitches have 3 prongs on them, it will work to replace the pots that are in the Arcade1UP pedals. Now, some of you think the prices are high for the pedals, but keep in mind you do not have to buy new. For example, the dual pedals can be found on eBay from anywhere to $80 to $100 last I checked. You may have to clean them up as they would be used. However, if you put in the time to clean up, they can save anywhere from $50 to $70. Also, I plan on testing other pedal sets that are cheaper, but have not received them yet as of this video posting. However, once I get them, I will post another video testing to see if they work. Finally, any pedals I use will be posted in the description field of this video with a link to purchase, including places to buy, the wiring, and any other tools I use to get the pedals working. So, with all that said, let's go ahead and test the first set of pedals, which would be the 2 modular pedals with 5K pots. So here's the list of parts you'll need to assemble the modular pedals. You will of course need the modular pedals with the 5K pots. You will need 2 of these, one for the throttle and one for the brake. Then you'll need a 3.5mm 4-pole determinal block adapter. This comes with a precision screwdriver, so you can unscrew and screw down the terminal block screws. Then you'll need a 3.5mm 4-pole male to female extension cable. Because the 3.5mm 4-pole to terminal block adapter is short, you will need an extension cord to give the cable more length to plug into the female 3.5mm port that is connected to the Arcade1UP encoder board. Also, make sure the 3.5mm extension cable is 4-pole or the pedals will not work. Next, you're going to need some arcade buttons quick connect wire pair cables that have a 0.11 inch connector. The ones I purchased have a set of 10 cables in them. Now, you do not have to purchase these cables. If you have the experience and the tools, you can make the cables yourself. However, I tried to make the projects as simple as possible, so having the cables pre-crimped and make things a lot easier for some people. But again, if you want to make your own cables, you can. Just make sure the end is either 0.11 or 0.125 inches. Finally, you're going to need a wire stripper. The one I used, as stated in the parts list, is a double jaw wire stripper and crimper. It does not have to be this specific tool, and the tool can also be used as a wire cutter because we'll have to clip off some ends off these cables. However, if you already have wire strippers and wire cutters, feel free to use those tools as well. Okay, so the first thing we're going to do is we're going to clip the wires that we're going to need. So we're going to need 6 altogether for the potentiometer. So there's a pack of 10 in here, so we're going to pull out 3. And once we pull those out, we're going to cut off the white connectors off these because we don't need those. So we're going to take our wire stripper, wire cutter, we're going to cut off those 3 white ends, and that'll give us a total of 6 cables to use to connect to the modular pedals. So there's a second one, and then we're going to clip off the third one. Okay, so and once we get those all clipped off, we're going to strip the ends off each one. So again, we're going to take our stripper, and we don't want to strip off a whole lot, but just enough so that we can put those ends in the terminal blocks. Just kind of use your best judgment on how much you want to strip off the ends of the cables. Okay, so now that we have that stripped off, the last cable, we can set these aside for a moment, get rid of those other ends there, and we're going to look at the pedals now. And now if we look at how these pedals are set up, we're going to look on the inside here, and hopefully you can see where that potentiometer is. Okay, so I apologize for the picture of the potentiometer inside the modular pedal. This was the best picture I could get, and I know it's hard to see, but bear with me, you'll be able to tell what you need to do. So if you notice, we're looking straight at the potentiometer and the stem is pointing up, and you've got on the right you have the three prongs. Now because it's standing up, in the picture to the right, imagine if it was turned and those prongs were pointing towards you. So on the left, what we're going to do is we're going to make that the positive VCC. The output is going to be the middle prong, and the ground is going to be the right prong. So what we have to do is the wires that we clipped off the ends on, we're going to connect those ends into each of the prongs on the potentiometer. Now because the cables are white, all white, it doesn't matter where we plug it in right now. Again, the cable colors don't matter. It's just a matter once we hook it up to the 3.5 millimeter 4-pole to terminal block, then we have to make sure we know which cable is on which prong. Okay, so now we can plug in the cable ends into the prongs. Again, the left is going to be positive VCC, the middle is going to be the output, and the right's going to be the ground. But for right now, we're not worried about that because all these colored cables are the same. So we're just going to plug all three of them into the prongs. So just take your end and just go inside there and just push it in and plug it in. We're going to start on the one that's on the right or in the back, and then we'll go to the next one. Now, these ends may be a little tight and may be hard to push in, so what you may want to do is take your precision screwdriver that came with your 3.5 millimeter 4-pole adapter and push that in to kind of spread the spade out a little bit so it pushes in a little bit more freely. It should still be tight, but you should be able to push them in. As you can see, this one's a little bit difficult. So again, I'm going to just use a precision screwdriver to kind of stretch it out a little bit so it plugs in. And this is the middle one that we're plugging it into. And again, it's having a little bit of trouble getting it in. But if you do have problems, again, take that screwdriver, kind of stretch out the spade a little bit, kind of go back and forth with it, so that it just pushes in a little bit more easily and freely. And then once you get it in there, you're good. And then we'll do it for the third one. We'll plug that in. And once again, if it's a little tight, just take your precision screwdriver, move it back and forth in there to kind of free it up, and plug that in. And it plugs in. And now we'll do the exact same thing to the other pedal. Okay, so now once we got that other pedal set up, now we got all the cables hooked up. So now we're ready to connect all the cables to the 3.5 millimeter to terminal block adapter. Now again, we got all our wires, but again, they're not color coded, so we have to make sure we look and see which plugs into what. And again, the left is going to be the positive, the middle is going to be the output, and the right one is going to be the ground. So we're going to go from right to left here, and we're going to unscrew all the screws so they're all unscrewed, and then we're going to start plugging in the cables into the appropriate ports. Okay, so if we look at the images to the right, we have the legend for the 3.5 millimeter 4-pole terminal block legend, and then we have an image of the potentiometer. So the first thing we're going to do is we're going to plug in from right to left. We're going to plug in the ground cables. So the ground cables will be the ones to the right or all the way inside the pedals. So once we locate those cables, we're going to insert them into the terminal block, and we're going to put them in there as tight as we can, hold it with your thumb, and then screw it down. And then once you screw it down, give a little tug on the cables just to make sure nothing's loose. So the next set of cables we're going to plug in wires are going to be the positive VCC. because that's the second one going from the ground. The second terminal port going to the left would be the power or the voltage or the positive. So again, the prongs that the voltage is connected to on the potentiometers is the one on the left prong. So you want to make sure you get the correct wires, because again, the wires aren't color coded, so you're going to have to make sure you get the correct cable to plug in. And again, if you want to make your own cables and they're color coded, that's fine, but in this case they're not color coded. So find the voltage cables, and again, just unscrew the terminal screw that's on that port, push in the positive cables into that terminal port and screw it down. And then once it's screwed down, make sure it's tight, and then give it a little tug and make sure it's in there properly. Now the next cable or wire we're going to plug in is for the throttle output, and that's going to be the third one to the left. So right now we don't care which pedal, we don't know which pedal is going to be throttle or which one's going to be brake, but now we have to determine that, which one we're going to use for the brake and which one we're going to use for the throttle. So we're just going to take this one here and say this is the throttle. So just again, put your cable into the terminal port for the particular one and then screw it down, and screw it down tight. And then once you do, just give it a tug to make sure that it is connected properly. And then the final wire that we're going to plug in is for the brake. So this cable is for the brake. So we're going to plug that in, and then we're going to screw it down. Okay, so now that all the cables are assembled and connected to the 3.5 millimeter terminal block cable, I'm just going to use a piece of tape to indicate which pedal or which wire is the throttle. So I'm just going to tear off this piece of tape, and I'm going to locate the wire that's for the throttle, which would be the third wire here, and just put a piece of tape on there, and that will tell me which pedal is going to be the throttle. And then once that's put on there, that's pretty much it. Now we just now we need to build an enclosure or something to put these pedals on, because of course we can't have the pedals like this. We'll plug in our extension cord here, but we're going to have to build something to hold the pedals in place so that, and hide the wires, and that's what I'm going to show you next. So this is what I came up with to hold the pedals in place. Now you can do it any way you want. This is just the way I did it. So I cut a piece of 1/2-inch wood and cut it and measured it the same size as what the Arcade stock A1UP pedals were. And then what I did was I screwed the pedals in place down on the wood. Now you'll notice on the top here, I've got like a little rubber tile here. This was $4 from Harbor Freight, and it's got an adhesive on there, but it's not really good adhesive. So at some point I'll have to put screws in to kind of secure it in place to make sure it does stay in place, because it keeps falling off. Again, because the adhesive's not that good. But this was $4 at Harbor Freight. Now this one was $1.99 at Harbor Freight, and I put that on the back. So if I flip this over, the reason why I did it in strips was because on the left and right side, you know, I put those the $1.99 panels on there, and in the middle I cut it in half so I could cover the wires. So what I did here is I took a router and exposed the wires there and put the wires inside where I routed, and you notice at the end there I put a bigger cut so it holds the bigger end of that 3.5 millimeter 4-pole terminal block adapter. And so I cut the rubber panel so that I can cover that up as well. And again, that's something I'll probably have to screw down because again the adhesive's not all that great. But doing this, it covers the wires and it holds it in place. So now with all that done, we can now hook this up to the Outrun cabinet to make sure that everything works. Now again, this is just the way that I did it. Now you can come up with any solution that you want to attach these modular pedals to some kind of base. But this is just the way I did it, and it seems to work pretty well as far as holding it in place, and it's pretty sturdy. So now with all that done, we can go ahead and connect this up to the Arcade1UP cabinet and see if everything works. Okay, so now we're going to plug in the pedals into the Arcade1UP cabinet. Now, what I didn't take into account here is that although the wood I use is 1/2 inch, because of the treads, it kind of makes it actually a little bit thicker. So in order to get to slide this in, I have to lift the cabinet up a little bit so that I can push those pedals in so that they're held into place. And then, so once I lift it up and get them in there like that, and then just set the cabinet down. It's not too bad, but just, again, when you decide how you want to assemble these pedals, you're going to have to make measurements and stuff to make sure everything works. But it doesn't like put the cabinet on a tilt too much. So anyway, once we got that in place, find the female 3.5 millimeter adapter that connects to the encoder, and we're just going to plug in our extension cable, just like that. And with that plugged in, now we can actually test the pedals to make sure that they work with the cabinet. Okay, so now that we got the pedals hooked up, now we can turn on the machine and we can now start the calibration. Now the calibration I usually do 2 times. So I'll do it 1 time, let it save, turn off the machine, and turn it back on again. And by the way, you're not going to see any video come up on my screen here because I've got it streaming to my computer right now. So that's why you're not going to see anything on the actual Arcade1UP screen. It's all streaming to my computer. So to do the calibration, we're going to turn it on, and we're going to keep the start button and the music button pressed in at the same time. So we're just going to turn it on and keep those 2 buttons pressed in. So what's going to happen is, of course, you'll see the loading screen in the Arcade1UP screen. And, well, actually, you're not going to see the Arcade1UP screen. It's going to go right into the calibration. So you're going to press the start button to start the calibration. Now, the first thing you're going to have to calibrate is the wheel. So we're going to turn it left, and then press the start button. Turn it right, press the start button, and then let it go back to center, and press the start button. Now, the next one we're going to do is the brake. So the brake, of course, is going to be on the left here, which is right there. So we're going to press that down, and you can see it pressed down. So we're going to press start, then we're going to let up, press start, which is a good sign. We know that the brake's working. Now the gas, same thing, press down, good, let up, good, and then it's going to say press the start to calibrate the data, and then press start to it's basically saying it's updated successfully, and we're going to press the start key to exit, and then it'll go into the actual game. Now, like I said, I like to calibrate it twice, so I'm going to go ahead and turn this off and turn it on again and do the same thing. And again, I just find that doing it twice, it just ensures that everything's working right and everything's calibrated. So again, we're just going to start the calibration again. We move the wheel left, move the wheel all the way to the right, and then let it center. Then we're going to do the brake again, so we're going to press down on the brake, let up on the brake, start. Same thing with the gas, press down, start, let up, start. And then we're going to press the start key to start the calibration data or save it. And it's updated successfully. And now we can go into the game. So now everything should work. And like I said, once it comes up, we'll go ahead and test a game. We might as well just test Outrun since that's the namesake of the cabinet. So here we go. So we're going to turn. So it's working because we're pressing the gas pedal to continue, so that's a good sign. Okay. Now we're going to test play, so we're just going to play game. Start music. Get ready. Let's see what happens here. You can see the gas is working. Working. We're going to test the brake. See if the brake is working. So yeah, so those pedals are working. So it's a good sign. Everything seems to be working with these pedals. Now we'll go ahead and test the next set of pedals to see if those work. Okay, so the next set of pedals we're going to test with are the dual pedals with the 5K pots. So for the part list for this, you're going to need the dual pedals with 5K pots. You're also going to need one 3.5 millimeter 4-pole to terminal block adapter, which comes with a precision screwdriver. You're going to need the 3.5 millimeter 4-pole male to female extension cable, as we explained before, because the cable terminal block adapter is so short. You're going to need that to extend the cable, and we're also going to need your wire stripper and wire cutter. And again, the tool I use is listed here. It's a double jaw wire stripper and crimper, but if you have your own wire strippers and wire cutters, you can use those as well. Now you'll notice that I didn't put any cables on here because the cable assembly is already built connected up to this particular pedal set, so we don't have to worry about connecting any wires as everything's connected up. Okay, so here's the pedals right here, and if we turn this around, we're going to see that the pedals actually have the wiring assembly already connected up. So if you turn it around, you can see that if we press down the pedals, you can see that the cable's already hooked up to the potentiometers. And how they do have this is they have these daisy chains. So you can see the red indicates the voltage and the black indicates the ground. And the voltage is on the top. The yellow cables or green cables are the output for the throttle and the brake. And then the bottom prong on the potentiometer is for the ground. Now you'll notice that that red wire, for example, comes over to this potentiometer over to the left, which is the throttle, and then another red cable comes out to the connection here. So you notice that there's only 4 wires because they're daisy chained from the brake potentiometer to the throttle potentiometer, and then from the throttle potentiometer the voltage comes out to this cable. And it's the same thing with the ground as well. So what we're going to do is I'm going to go ahead and clip this wire off because I couldn't find it. Normally I wouldn't clip it off, but I couldn't find a connector for this to connect it, so I'm just going to clip it off here. So we're just going to take your wire cutter and cut it, and then once you have the wire cut, then we're going to strip the 4 ends of the cables. Again, just strip off enough to where you can you got enough wire exposed to where we can put it into those 3.5 millimeter terminal ports. And we're going to do that for all 4 of the cables. So we're going to strip that one, and we're going to strip this one, and then finally we'll strip the final one. So now we have all 4 of the cables stripped. Okay, so with all 4 of the cables stripped, we can connect up the 3.5 millimeter 4-pole terminal block cable to it. Now over onto the right, you'll see a picture of the legend of how we're going to connect this up. Now because these cables are color coded, we know what color cables go to what. We know that red is the voltage, we know that black is the ground. The only thing we need to do is trace out the green cables to find out which one's on the throttle and which one is on the brake. So the first cable that we're going to hook up, we're going to go from right to left. So the first one we want to hook up is the ground. So that's going to be the black cable. So we're going to just slip that in to the terminal port, and we're going to screw it down and make sure it's screwed down tightly. And once it's screwed down, we're going to pull on it a little bit just to make sure that it's secure. Now the next port to the left is the voltage. So we're going to take the red cable and we're going to put that into the voltage port. So we're going to put that in there, and then we're going to screw that down. So the next one to the left of that is the throttle output. So we need to trace the cable from the throttle output and find out which one it is so we plug it in right. Now the throttle, because we're looking at it from the back, the throttle is on the left here. So now some of these cables are tied down. If you wanted to, you could clip off the ties, but I'm not going to. So I'm just trying to make sure I trace out the right cable that is the throttle. And it's taking me a minute here because everything's in there tied down. These cables are tied down. But once I determine which one is the throttle, which I believe it's this one here, if I see it correctly. So yeah, so that one's the throttle. So now we're going to plug that into the throttle port. And we're going to slip it in there, and we're going to screw that down and make sure it's screwed down tightly. And once that's screwed down, we'll pull on it a little bit to make sure it's secure. And then finally, the last one is the brake, and we'll put that into the brake port. Slip that in there. And then tighten that down again. And once it's tight, screwed down there tightly, we'll just do a little pull on it just to make sure that it is in place, and it is, and everything's good. And so that's it. And then we're just going to plug in the extension cable onto that one, and that's it. And we can go ahead and plug this into the Arcade1UP and test it to make sure it works. Okay, so before we put this in the riser itself, that's what it's going to go into. I want to test the pedals first to make sure they work. Otherwise, I'll get everything in the riser and everything else. And if it fails, then I just have to take it back out again and test it. So we're going to test it now just to make sure everything works. So again, we're going to take our, find the 3.5 millimeter female right there. And plug that in. Okay. And now we're ready to calibrate. So we're going to go ahead and turn it on. Press start and music button at the same time. And after the loading screen, we get the calibration. So we're going to press start to calibrate. Move the wheel left, press start. Move the wheel right, press start. Go back to center, press start. And now we're going to press down the brake. Now, one thing I forgot to mention is, as you can see when I'm pressing the brake down, it goes all the way down. This is one of the reasons why I forgot to mention when I do the calibration twice, because when you hook up new pedals, sometimes that red bar there will be like in like a little lower, and then when you press down the brake, it doesn't go all the way down and it doesn't go all the way up. So that's why I do the calibration twice, to make sure that it does do that. So in this case, I'm pressing the brake down, it goes all the way down, which is good. Press start, go up on it, press start. We'll do the gas, down, press start, go up, press start, and press the start button again, and it's saved. Now again, I like to do the calibration twice just to be sure. So we're going to turn it off, going to turn it back on again, start music button, and do it one more time. For it to come up, there we go. So I'm going to press the start button, and wheel left, wheel right, go in the middle, brake down, brake up, gas down, gas up, and configuration is saved. Press the start button twice. And so everything looks good. So we're just going to go into a quick game to make sure that those pedals do work correctly, which I think they will. Okay, so we'll just go an outrun here. There we go. Press, there we go. Gas is working. So start a game.
Get ready.
So now we started the game. Gas is working. Press the brake here in a moment. So I get in the throttle. So get down this turn here. And the brake. See, it's braking. So everything's working. So now that we know the pedals are working on this. Now we can. Now I'm going to put this in the riser and secure it down, and then set the cabinet on top of there and then test it again. Okay, so now we need to put the pedals in the riser. So I have a Arcade1UP, riser that's 12 inches. Just to kind of show you what's going on, because I have a sit down Outrun, so I don't have the 15-inch riser. But either way, this is how you'd have to do it. So you have to measure the dimensions of the pedal assembly that's in the back, and then basically just have to cut a hole in the front and in the panel behind that, so that the pedals can slide in and you can screw it down. Now, how I cut the hole is I tried to make sure that the bottom of this is as close to the bottom of the riser as I can. And then once you make the cut and make the measurements, you just slide your cables in there, and then you slide this in place, and it goes in there. Now there's 4 screw holes. Once you get that in there, then you just take a drill and drill 4 screw holes. Now I use 10-24 number screws, so you just have to find the right drill bit so that the that screw could go in there. And then basically once you have it in there, then what you would do is right here, you'd put the screw in, and then you'd put a nut in the back, to hold it in place. Now, some people may think that this is, it's 1/2-inch MDF, so maybe it's not going to be strong enough to hold the pedals when you're pushing down on them. So if you want to, you can put a piece of 1/2-inch wood, plywood, or MDF, or whatever the case may be, in there as well, to line it up on the holes of the dual pedals. That way, I think it just gives it an extra amount of strength. So when you're pressing down on the pedals, I don't think you really need them, but it just gives you an extra, extra strength. So when you're pressing down on the pedals, you don't have to worry about it breaking. Now again, this is the 12-inch, Arcade1UP riser. Now I know the Outrun stand-up comes with a 15-inch one, and it already has a hole inside it. So what you may want to do is either cut the front and the second panel, make a custom, cutout for that, and replace the front and the second panel with the stock one, so that if you want to return it to stock, you can without having to drill any holes, and you've got your replacement panels that you can cut and put this in. So that's always an option. So I'm not going to use the 12-inch riser. I have a different solution in mind for my riser, because my Outrun was a sit down and didn't have a riser, so I had to buy one, and it's an 18-inch riser, and I'll show you that now. So this is the riser I'm using. So this is an 18-inch riser that I purchased on Amazon that someone makes. The reason I went with this is because I needed a riser because I have a sit-down Outrun. Now, I went with the 18-inch one. I could have built it myself, but I wanted to save time. I didn't really want to build the riser, so I bought this. This was around $100, not including shipping. It kind of looks like it wouldn't hold, but it does hold the cabinet in place. Now, you'll see I put wood panels here to kind of, give it a little bit more, hold it in place a little bit more secure. Again, I don't think you have to do that, but I just did as a just in case. So again, doing the same thing, cutting it the way I did, made sure it kind of lined up on the bottom there, and then I drilled my 4 holes to hold the screws in place. Now I'm using these screws I got from Zuzo Hap. It's like 100 screws that came with it, but it's 10-24 screws. So essentially we just slide in the screw into the holes after we drilled them, and then we're just going to take some I just usually take a washer and then a nut and screw the nut on there to hold it secure in place. And that's about it. So I'm going to do that now and to secure it in place, and then we'll go ahead and move this and hook it up to the Arcade1UP Outrun. Okay, so I've got everything assembled. I got everything screwed in. Pedals are working. So now what I'm going to do is I'm going to put the cabinet on top of this. And once I get that on top, then I will go ahead and test it again to make sure it plays correctly. So I'm just going to take the cable here. Normally I would put it on this lip here so I could attach it on, but since it's long enough, I'm going to go ahead and attach it to the Arcade1UP 3.5 millimeter connector. And then once I get that connected, then I will go ahead and put the Arcade1UP on top of the riser. Alright, so this is what it looks like when it's on the stand. I've already plugged it into the 3.5 millimeter cable. There are the pedals. As you can see, I can press down on them. Works very well. So everything's screwed in. So now let's turn it on and make sure everything works. Now, I'm just going to turn this on to see if it works. I don't have to calibrate it because we already calibrated them, so it should just work. So I'm trying to try to stand back here a little bit to make sure you can see me pressing the pedals. So once we get in, I'm also watching the screen on the left here, so I'm kind of go. There we go. Okay. So now let's see if it works. I'm going to press start. Start again. And
Get ready.
let's see. So we got the gas working. Everything is working. Pressing it. This is working. Get it straight in. I'll press that. Great. Gas again. So yeah, everything seems to be working. So those pedals have worked, and now we can move on to the microswitches. Okay, so to finish up this video, I'm going to show you how to hook up microswitches to the Arcade1UP Outrun cabinet. Now, in normal circumstances, you wouldn't do this, but if you're going to hook up arcade pedals, some of those arcade pedals have microswitches on them, so it's good to know how to hook them up, and just to show you that this process does work. So for this part of it, you're going to need two arcade buttons. In this case, I have a black and green one. The green's going to be throttle, and the black is going to be brake. Then you're going to need two arcade microswitches. And you have to make sure that they're 3-prong. If they're 2-prong, they're not going to work. Then you're going to need a 3.5 millimeter 4-pole terminal block adapter with the precision screwdriver, just like we did with all the others. Also going to need that 3.5 millimeter 4-pole male to female extension cable, because again, the cable with the terminal block is short, and you'll need an extension cable so that the cable can reach the female 3.5 millimeter adapter that's on the Arcade1UP encoder. You're also going to need zero delay USB encoder wire harness with 0.187 inch terminals. Now this actually, the one I usually get comes with 20 of these cables, and we're just going to need 3. Again, just like we did previously, if you can make your own cables, then go ahead. You don't need to buy these pre-wired or pre-crimped. I just buy them pre-crimped because, again, people that are doing these projects, I try to want to make it as simple as possible for them without having to buy any specialized tools. But if you're used to making your own cables, go for it. Just make sure that the terminal ends are 0.187 inches. And then finally, you're going to need a wire stripper and a wire cutter. Again, the tool I use is listed here, but if you have a wire stripper and wire cutter, then of course use that. You don't need to buy this tool. So with that being said, we can proceed on to hooking up these arcade microswitches and seeing if they work with the Arcade1UP Outrun. Okay, so the first thing we're going to do is we're going to attach the microswitches onto the buttons. So we're just going to take a microswitch, as we figure out which way to connect this up. We're going to go ahead and put it in there. Snap it in place, and we're going to do the same thing with the second button as well. Okay, so we got the micro switches connected up to the buttons, and now we're going to prepare the cables with the 0.187 inch terminals at the end. So what we're going to do is we're going to clip off the white ends on here. So what we're going to do is we're going to get our clippers and wire cutters, I should say, and we're going to clip those ends off. So we're just going to do each one, clip it off. Do it for the second one, and do it for the third one, which will give us 6 cables or 6 wires to connect to the micro switches. Now for each end, we're going to strip the end off each one. So now that we got those set, we'll get our wire strippers, and we're just going to strip off a little bit of the end on each one. Do that, and we're going to repeat that for the other 5 cables as well. Okay, so we stripped the last cable on there. So now all 6 of those cables are stripped. Now we're going to go ahead and connect them up to the micro switches. Now, because although we have 3 cables that are blue and 3 cables that are white, at this point it doesn't matter where it's plugged in to the terminals, because we'll determine that later once we actually connect the cables up to the 3.5 millimeter 4-pole terminal block adapter. So we're just going to plug in the cables. But what I am going to do is, for the white cables, I'm going to make the white cables the output for the throttle and the output for the brake. And then the other ones I'm just going to plug into the positive and negative. Again, the color of the cable doesn't matter. It's just us knowing which prong plugs into which terminal output on the terminal block adapter. Okay, so now that we got all the terminal cables hooked up to the micro switches, we're now ready to hook these up to the 3.5 millimeter 4-pole terminal block. So we're going to unscrew the screws for each terminal port, and we're going to start again from the right to the left, and we're going to start with the ground. So looking at our diagram over to the right, the legend, the ground for the micro switch is going to be on the bottom there, how we have them oriented. So we're just going to take the cables. Now you may have to tighten the wires a little bit by using your fingers to twist them together. And what we want to do is we want to push that in there as far as we can, as tight as we can in there. And once we do that, we'll go ahead and hold it with our thumb, and we'll screw down the screw. And we want to get it tight. And then we want to pull on the cables to make sure that they are holding in place. Now, if the cable slips out, what you'll have to do is unscrew the screw again and then pull it back out again. So we're good there. Okay, and now we can move on to the voltage, the positive VCC. So that's going to be the middle prong on the micro switches. So again, we're going to grab those, and we're going to kind of twist the wires a little bit to make sure they go in a little bit cleaner into the terminal block. And we're going to move that, and then we're going to put that in there. Make sure we got it lined up right. Make sure we kind of can get it in there. Sometimes if you don't twist these, sometimes the wires will not go in properly, and when you try to screw down the terminals, the screw for the terminal port, the wires won't connect and the wires will fall out. So we just want to make sure that's in there tight. And then once we do, then we will then take our screwdriver, precision screwdriver, and screw it down. And we want to screw it down as tight as we can to make sure that the cables don't come out. So as you can see here, when I pulled on it, the cable came out, so it wasn't secure on there. So I'm going to unscrew the screw again, and we're going to try to put it in there again. trying to twist the cable, the wires a little bit so we can fit it in there. And we're going to try again. So we're going to line these up, put it in the terminal block there. I'm going to do it tight. Now, sometimes what you may want to do is screw it down, get it a little bit tight, then let go of the wires and then push them in again. Because sometimes when you screw them down and when it's tightening the screw to the terminal port, sometimes the cables will slip. So you want to just let up a little bit. After you screw it down a little bit, push it in some more, and then screw it down to permanently make it tight. And again, once it's tight, do a little tug, and it's in there. So we'll move on to the next cable, which is the third one, which is the R, which is going to be the throttle output. So we know that's the green one button. So we'll take that cable for the output, which is only one cable, and we will slip it in there, put it in there kind of tight, and then screw down the screw to tighten it to the terminal port. And once we get that screwed down, screw it down, and then do a little tug on it just to make sure that it is in place, and it is. And then finally we're going to hook up the brake output, which would be the L port on the terminal block. Slide that in there, and let's try to get it in there. And once we get it in there, hold it in place with your thumb, screw down the terminal port, keep slipping, there we go, screw it down, again make it tight, and then tug on it a little bit just to make sure it's secure. And there we go, all the cables are plugged into the 3.5 millimeter 4-pole terminal block cable. So, and once we get those plugged in, then we plug in our extension cord, and there you go. And now we're ready to test this on the Arcade1UP cabinet. Okay, so now we're at the cabinet again. Here are our buttons, and we're just going to plug the 3.5 millimeter adapter into the 3.5 millimeter female to the Arcade1UP encoder, and now we're ready to test. Okay, so now they got the pedals hooked up, so we're going to turn this on again. This is going to be a little hard for me because I got to hold the push buttons, but we're going to see if we can get it done. So again, we're going to do the calibration first. So we're going to turn on the machine, press start and the music button at the same time. You should go in the calibration screen. So there we are. So we're going to press the start button to start it. And the first thing we're going to do is the wheel, so we're going to move it left, press the start button, move it right, press the start button, then bring it back to center, press the start button. And of course the next thing is the brake, so again the brake is the black button, so see we're going to press down on it, it's working, so we're going to press start, and we're let up on it, press start, and finally we're going to do the throttle. So we're going to press down on it, press start, go up on it, press start, and save the configuration, which is a good sign. So we're going to start, and then data successful. Now again, what I like to do is I like to do it twice. So we're going to go ahead and turn it off again. If you're okay with it just doing it the one time, that's fine, but I just find doing it twice helps sometimes. I've run into problems where even though it looked like it calibrated, it didn't calibrate correctly, so that's why I do it twice. So again, we're going to press the start button to calibrate, go left, go right, back to the middle, go on brake, so we're going to press down on the brake, which we're here, up on the brake, and same thing for the throttle, go down, go up, and we're going to save it, start it, and we're going to boot up the game. So now that all that's there, we can go ahead and test it. So Again, it's going to be a little hard for me because I got to hold the buttons and drive, but we'll do a quick test. Let's go ahead and just do outrun. Oh, well, I'm press the gas button, so let's see if that works. So that's working. Alright. Start. Free play. Alright.
Get ready.
So press down on the throttle. See it's throttling. Looks like it's working, so we're going to go into high gear. Press brake. Yep. So the brake's working, throttle's working, so that's how you do the microswitches. If you don't have pots, if you want to do microswitches, you can hook it up to do that, and everything seems to be working and everything's connected up. So those are the 3 sets of pedals that I did in this video. The first ones were the modular pedals, the second one the dual pedals, both from A1UP, and then the third one I just tested microswitches to show you how to do that. Now there are a number of other pedals out there that will work, that will possibly work, that I have on order. The last one I bought from A1UP, which is for about $105, is the Batman game dual pedal assembly, and that has a microswitch for the brake and a Hall effect sensor for the gas or throttle, which I'm curious to see if the Hall effect pedals work. You also have cheaper alternatives, such as shown here. The one on the left is a Hall effect pedal for like about $14, and then another one is just a foot pedal for about $13. Just curious to see if those work. And then there was one I bought from another one I bought from AliExpress, is specifically for an outrun cabinet. It has 2 potentiometers in there, and to see if that works. Then I also bought pedals for the throttle and the brake for, it looks like, for Logitech G29, I believe. I just want to see if those work. I got those in, but I haven't tested them yet. But they have 10K potentiometers, not 5K. So I'm curious to see if that works. And then finally, I have another cheap one for like about $3, but it's like $13 shipping. And again, it's an electric scooter pedal. And I'm going to see if that works as well. And this will be done in another video. Because I haven't got all the pedals in yet, but once I get them all in, I will test these and put another video to see if they actually work or not. Okay, so that concludes how to hook up arcade quality pedals to your stock Arcade1UP Outrun cabinet. We went over how the stock pedals operate using 5K potentiometers connecting to a 3.5mm 4-pole cable. Once we tracked down what each wire was doing, we were able to connect arcade pedals using 3.5mm 4-pole terminal block cable to make it easier to wire the pedals. We did this 3 different ways, one with a set of modular pedals, the second with arcade dual pedals, and the third with microswitches replacing the potentiometers. All 3 worked successfully, and I have more pedals on the way to test further to see if other pedals will work, specifically Hall effect pedals, which I'm curious about to see if they work. I hope this video was helpful. Please note that links to all the parts I used are in the description below. And thanks for watching, and see you in the next video.